It's cheap, it's green, and it's created naturally underground. We'll look at why companies around the world are rushing to capitalize on white hydrogen. Well, geologists around the world are calling it the new gold rush, a global scramble to try and harness the power of hydrogen. The gas is commonly used as a fuel or as an industrial material, most famously to make ammonia, which is used in fertilizer. Its most common iteration is so-called gray hydrogen, the creation of which involves methane and emits carbon emissions. In a push to limit those emissions, industries have been turning to green hydrogen, where it is created thanks to renewable energy and thus without any emissions. And there's now also an increased interest in natural hydrogen, also known as gold or white hydrogen. This is naturally generated underground, which makes it both cleaner and cheaper than either gray or green hydrogen. Well, according to Rystad Energy, the hunt for these deposits is gaining momentum. At the end of 2023, 40 companies were searching for this white gold across the globe, with efforts in the US, Canada, France, Albania, South Korea, and Colombia, among others. In 2020, only 10 companies were involved. Well, for more on this story, we're joined by Min Khoi Le, who is head of hydrogen at Rystad Energy. Thank you for being with us, Min. Can you give us a sense of just how much more cost-effective and carbon-effective natural hydrogen can be?
Thank you very much. It is my pleasure to be on the show today. For natural hydrogen, I think it brings a lot of positive and opportunities there. Let's say in terms of the energy transition, most of the hydrogen that are being looked at is either blue or green hydrogen. And for green hydrogen, which is made from renewable energy, the prices range that we could be looking at is about $10 to $12 per kilograms. For natural hydrogen, from the reported numbers that we are seeing, it could be down to below $2 per kilogram, so about 5 times cheaper than green hydrogen. Of course, for green hydrogen is normally zero carbon associated if you use dedicated renewable energy. However, for natural hydrogen, there is a little bit of carbon emission, but it is not as bad as, let's say, you make hydrogen from natural gas. The emission that are associated with natural hydrogen is normally associated with the drilling process or any contamination of other gases in the extraction process. So if those are handled well, we could be looking at a very low emission intensity for natural hydrogen.
And what role do you see natural hydrogen play in a clean energy mix in a net zero world?
Yeah, definitely could play a very key role. In Rystad Energy, when we're looking at a potential hydrogen demand to meet some of our net zero and climate goals, it could range from anywhere between 250 to 450 million tons of hydrogen. That is 4 times more than the amount of hydrogen that we use today. So there is a lot of room for many different sources of hydrogen to play in this role. There hasn't been a lot of confirmed numbers on what these reservoirs of natural hydrogen could hold, but some of the numbers that indicated could play a significant amount within this range to help us reaching to our target.
You mentioned there's some unknowns there, like the actual reserves around the world. What are the main challenges, do you think, to the development of hydrogen currently?
Yeah, so if we're talking about the development of natural hydrogen, the only operating well reservoir at the moment was found by accident, and therefore there hasn't been a lot of research and understanding on exactly the size of reservoir, the rate of the amount of hydrogen that you can extracting from it. So the process of understanding this will definitely play a key role for us to see what is the real role of natural hydrogen. Of course, any reservoir that worth developing needs to be of a certain size.
France has issued in the past year or so exploratory permits for natural hydrogen sites, either in the east of France, in the Lorraine region, or in the southwest of the country as well. What can we expect from these particular sites?
Yeah, we do see those exploration license being given out, and we do hope that the progress can be made very quickly to see if we can find and start drilling and see if we can find any natural hydrogen in France here. Traditionally in Europe, when we talk about clean hydrogen, the main conversation has been about renewable energy fed electrolysis, and therefore the renewable energy demand to make this green hydrogen could be quite significant. France is definitely playing a key role here as well, with some of the renewable hydrogen projects already in progress. With the natural hydrogen coming on board, if we can find significant amount, could definitely help us reaching closer to the target of not only France but of the European Union as well, with the potential of the backbone network transporting this hydrogen outside of France itself.
And finally, the only operational white or gold hydrogen or natural hydrogen project in the world is the one in the small village of Burakebgubu in Mali. And it's been on operation for decades. You mentioned it earlier, actually. They found it by accident about 3 decades ago. What does this particular project tell us about this particular energy source and how it could be used in developing countries especially?
Yeah, I think when we look at the project in Mali specifically, I think we can take a few key takeaway from this. One of them is it's being used to power a fuel cell to power the village around this site. I mean, it has that potential to provide remote powers and potentially extend wind other application of hydrogen, such as transportation, coming into play. But it also highlights a potential negative there, and that is hydrogen is still very hard to be transported in its gaseous form. And that means if you want to really use this hydrogen to demand centers, to industry, to potential transportation, there need to be a midstream development, whether that's pipeline or the transportation process, converting to other carriers perhaps, in order to really make use of this. That has been always the challenge for hydrogen in the past and even now.
Minh Khoi Lê is head of hydrogen at Rystad Energy. Thank you so much for sharing your insights with us.
No worries, it is my pleasure.